So operators in Python. So there are many type of operators in Python. But before looking at operators, let's see what is an operator. So if we have this expression like a plus b, right? In this expression, this plus is an operator, and this a and b are operands. A and b are both operands. So this operator operates on these operands. So there are many types of operator. Few are listed here. This is arithmetic operator, comparison operator, and then some special operators, and so on and so forth. So let's see those operators one by one. So arithmetic operators, plus, minus, multiplication, etc., they are called as arithmetic operators. So let's see those operators one by one. Let's say here I have x and y, two variables. We are assigning this 7 to x and 2 to y, right? So in the memory, x gets 7 and y gets 2. Okay. Now when we apply plus operator on this x and y will be added, and the result will be here 7 plus 2 9. So that will be printed here, right? So let's try some other operators here on this x and y. So if I do x minus y, I get the subtraction 7 minus 2 as 5. And then if I do division, let's see what I get. I get the division of x and y. So I get 3.5 because 7 divided by 2 is 3.5. Now there is a operator called as modulo division. There is an operator called as modulo division, which is this one. So what it returns, right? When I divide this 7 by 2, right? What I get, 2 6, 2 3s are 6, 2 3s are 6, right? So here this 3 is called as quotient, right? And this is called as remainder. This is remainder, right? So this 1 is a remainder, and this modulo division returns me the remainder. Modulo division returns me the remainder, right? So when I use modulo division operator here, so what I get is the remainder. Let's check it out. So 1 is the remainder. I get 1, right? Then I have this floor division. So what is floor division? Let's do it first and then try to understand this, right? So if I use this floor division, so 3. Now what is that, right? Now when I do this division, 7 by 2, what I get is 3.5, right? I get 3.5 because 2 into 3.5 is 7. 7 by 2 is nothing but 3.5. In floor division, I get the lowest nearest integer of this 3.5, which is nothing but 3. Lowest nearest integer, that is 3, right? So I get that. So in other programming languages, in C, C++, we get this. This is in fact nothing but quotient, right? This is in fact nothing but quotient, right? So we get quotient when we do this floor division, right? So now there is another operator called as exponent. So let's see what we get when we use exponent, right? Exponent is double star. So when I do that, right? So 7 power 2 exponent is nothing but 7 power 2. It is nothing but 7 square here. Power 2 is square. So 7 power 2 is 49. If I use y as 3, so 7 power 3, let's see what we get, right? 343. That becomes 7 cube, right? So this exponent is nothing but power. Okay. So these are some arithmetic operators. So let's see some comparison operators. Right? So there are these comparison operators: greater than, less than. This double equal to is actually equal to. This is comparison equal to. Now why we use that? To check whether two operands are equal or not. For example, A equal to B, right? So this operator here is called as comparison operator, which will return true if A and B are equal. This will return false if A and B are false. So if I use A greater than B, this will return true if A is actually greater than B. For example, 10 greater than 2. So this will return us true because 10 is greater than 2. So comparison operators are used like this. So for example, here we have A as 10, B as 20. if I do this a less than b, so this will return true if a is less than b. Here in this case 10 is less than 20, so this will return true, so this will print true, right? Now a equal to b, a is 10, b is 20, a is not equal to b, that's why this will return false, right? Okay, so these are comparison operators which you can use, right? This operator is called as not equal to, greater than equal to, less than equal to, not equal to, right? So this not equal to a, not equal to b, this will return true if a and b are not equal. Okay, so let's see other set of operator called as logical operators. So what are different logical operators available? So there are many logical operators, but we'll see quite a few here: and, or, and not, right? So from set theory, you might have seen this and, or, and not operators. If you have studied set theory somewhere in the high school or in college. Okay, so what is AND operator? If you have two operands, A and B, so if A is true, B is true, this A and B will return true. If A is true, B is false, this will return false. If A is false, B is true, this will return false. If A is false, B is false, this will return false, right? This is AND operator, right? Actually, A and B are taking Boolean values. A and B are taking Boolean values, and when we apply this AND operator on A and B, so we'll get either true or false. Okay, so that is the truth table for AND operator. Similarly, the truth table for OR operator will be A or B, right? So this OR will be true when either A or B or both are true. So here A is true, B is true, so A or B will be true. Here A is true, B is false, so A or B will be true. That means at least one must be true, either A or B, right? So here this will be true, here this will be false. This is A or B. And this not operator simply negates the operand, right? Either when I use not on A, so this not operator will, if A is true, it will make it false. That is not operator. So now let's see this A and B, right? So A is true, B is false. So A is true, B is false. A and B should return false, because for AND operator, both A and B must be true. You see, this is returning. Just a moment. So here, if you see false. Now, if I make this as true, both B is right. Now A is true and B is true. Both are true. So this AND should return true. So this AND is returning true, right? Okay, so these are the AND operators in Python. So let's see now bitwise operators. What are bitwise operators, right? Now let's say we have this A as 10 and B as 4. Now how can I represent A 10 in binary? It is 1 0 1 0, right? In binary. Why this is 1 0? When you want to represent something in binary, you start from 2 raised to 0, 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, so on and so forth, right? So when you have this 10, how can I write 10? 10 as, right? So 10 is nothing but, so this is nothing, so this is 8, so 10 is nothing but sum of 8 and 2, 8 plus 2, right? 8 plus 2. So 8, where I get 8 here, 8 in this sequence, 8 is this, right? This is 8 and this is 2, right? That means these two locations will be 1, others will be 0. So this, so in 4 bits, so this is 1 here and this is also 1 here, others are 0. So that's why binary representation of 10 is 1 0 1 0. Similarly, binary representation of 4 is in this sequence only 4 is this one, right? So this will be 1, others will be 0, right? So that means 0 1 0 0. So this is binary 10 and binary 4. So bitwise operator operates on bits. So these are called as bits, right? So when we do AND, 0 and 0 will be 0, right? A is this is A, this is B. So when we apply bitwise operator, so this operates on bit level, right? Bit level like this. So 0 or 0 0, sorry, 0 and 0 0, 1 and 0 will be 0 again. So 0 and 1 will be 0 again. So 1 and 0 will be 0 again, right? So this AND will be 1 when both A and B will be 1. 1 and 1 will be 1. 1 and 0 will be 0. 0 and 1 will be 0. 0 and 0 will be 0, right? So the result is 0. So bitwise operator result is 0. So we get 0 here. So let's execute this. If I execute this, we get this 0, right? Now this the result of OR, if I do the result of OR, let's check what will we get if I do OR. A is 1 0 1 0, B is 0 1 0 0. If I do OR, bitwise OR, 0 1 or 0 is 1, 0 or 1 is 1, 1 or 0 is 1. So I should get this. Now what is this? This is nothing but 2 raised to 3, 2 raised to 2, 2 raised to 1 and 2 raised to 0. So this is 8, 4, 8, 4 and this is 2, 0. So 8 plus 4, 12, 12 plus 4 is 14, right? So this number is actually 14, right? So so let's see what we get, right? If I do OR is represented by a single line here, this line, right? So we should get 14 here, right? So we got 14. So this is bitwise OR, right? Bitwise OR operator, which is giving us 14. You can see here 14 we got, right? Okay, so these are the bitwise operators. Similarly, we have a NOT and XOR. So let's see the assignment operator. So in the assignment operator, we have this operator is called as assignment operator, right? So this is not actually equal to operator. When we say A assigned to B, that means we have a variable A, and to that we are assigning value 10. So 10 A assigned 10. So right. So now this is shorthand notation for A is equal to A plus 10. So A is equal to A plus 10 can be written like this: A plus equal to 10, right? So these are same. These two expressions are same. This is just shorthand notation for this long expression, right? So if you do this, if we execute this, let's see what we get. So if I execute this, right, so we get 20, right? That is nothing but A is equal to A plus 10. So A is already 10, so 10 plus 10 is 20. So 20 will be assigned to A. So likewise we can use this all the operators with I can write the shorthand notation. That means when you are adding something with itself, right? That means if you are adding something with A and assigning that value to A again, so we can write A is equal to A plus 10, A is equal to A minus 20, A is equal to A into 10, like that. So all this can be written like this, can be written as A plus equal to 10. So this can be written as A minus equal to 10. So this can be written as A into equal to 10, right? So that is how we can use the shorthand notation. So there are some special operators in Python. So what are those special operators? Let's see, right? So these are called as identity operators. So what is an identity operator? So uh, and not, is not. So are the identity operators in Python. Is and is not. Is and is not. So this is and is not. They are the identity operators, right? So what they do? They're used to check if two values are located in the same memory area, right? So the sole purpose of these operators is to check if the two values are located in the same area. For example, we have A is equal to 5. What Python does is, if we are storing 5 in some variable, and now if we are assigning the same value 5 to another variable, Python actually for example, here we see B is equal to, we are saying B assigned 5, right? So now Python says, already I have stored 5 in A, why should I give separate memory for B? I will use the same memory. That means I will refer B to the same memory, right? In fact, B refers to the same memory. That means A and B are referring to the same memory when they are having same value, right? Now, if I check is A equal to A is B, if I check that A is B, that means are A and B referring to the same memory location? In this case, yes, they are referring to the same memory locations, right? So let's check what we get, right? So if I execute this, right, I get true because A and B are storing same value. When A and B are storing same value, they refers to the same memory location. And you remember that this is true only for simple operators like simple variables like these variables A and B. This is not true for the variables, complex variables like list, right? You see, when L1, so in this case L1, though L1 and L2 are same, the values of L1 and L2 are same, but the memory location will be different. So this will be L1, 1, 2, 3. Let's say this is some memory address. Randomly I'm writing here 1000 memory address. Starting from 1000 memory address, we have L1, and L2 will be, let's say, on, though L2 is same, right? That will be on another memory location. Let's say 4000. Right? So memory address of L2 is 4000, memory address of L1 is 4000. That means L1 and L2 are not same memory location, right? So that's why if we do L1 is L2, that means is L1, are L1 and L2 referring to the same memory location? In this case, this is false. So if I execute this, we get false. But that will be true for simple variables like A, B. Right? Again, if we have a string, so this will be true. If we have a string, if I am storing master in S1, right, and master in S2, so S1 and S2 will be referring to the same memory location, right? So that's why if I use is not here, so S1 will be master, right? So when I store master in another variable, so what Python does is Python refers the previous location which we already used for storing master S2. So S2 will also refer to the same. So that means S1 and S2 are same memory location, right? So is not will return false, right? Is not will return false. So let's do it. Now if I do is will return true because S1 and S2 are same. If I do is, this will return true, right? S1 and S2 are same. Okay. So let's see the membership operators, right? So now this is one of the important operator. If I have this list, right, and I want to check whether something is the member of that list. For example, one. If I want to check is one in the list, I will simply say one in list. Name of the list is list. One in list, yes, one in list. One is there in the list. That's why it will return true, right? So similarly, that is true for the dictionary also. In one is there in the list, dictionary D, so one in D will also return true. One in list will also return true. So in is used to check the membership in, right? And not in. In and not in are the membership operators, right? So they will return true if uh, the operand is the member, right? For example, if I execute this here, so I'll get true, right? So not in, now if I say not in, this will return false because one not in list is false because one is in list, right? So this should return false, right? Similarly here, if I do this will return true. Now if I use 3 instead of 1, if I use 3, so this should return false because 3 is not the member of this dictionary, so this should return false, right?